Now in the next part of Introduction to Organic Chemistry, we're going to learn about a special type of organic compounds called fossil fuels. Alright, so what are fossil fuels? Long time ago, when dinosaurs roamed the earth, and then they died, and then their remains are being buried in the soil. They sink to the seabed, and over millions of years, alright, they are subjected to the heat from the earth and the pressure, and then their remains are being converted into organic compounds. Alright, so since these organic compounds are obtained from the remains of plants, animals, dinosaurs that lived long time ago, we call them fossil fuels. Okay, fossils meaning the remains of the animals, plants, dinosaurs that lived long time ago. Why do we call them fuels? Because these organic compounds can be burned. Alright, can be burned to produce energy. Alright, or often they are being used to produce energy. Alright, so these organic compounds that are formed over millions of years from the remains of plants, animals, dinosaurs, alright, which now we harvest to burn to produce energy, we call them fossil fuels. Now there are two types of fossil fuels. Okay, natural gas, which is mainly your methane. Alright, methane is CH4, and petroleum. Okay, petroleum is also given the name crude oil. Alright, so they mean the same thing. Okay, crude oil is a thick black liquid. It actually contains a mixture of organic compounds, or more specifically a mixture of hydrocarbons. Alright, now what are hydrocarbons? You can actually guess from the name. Hydro means hydrogen, carbon means carbon. Alright, so hydrocarbons are compounds that contain carbon and hydrogen only. Okay, so compounds that contain carbon and hydrogen only, we call them hydrocarbons. Okay, and petroleum is actually a mixture. If you can recall, mixture simply means that they are not chemically combined, they are just mixed together. Okay, and in this mixture of hydrocarbons, you can have compounds that have very few carbon atoms, like only 5 carbon atoms, all the way to compounds that are very huge, that contains like 500 carbon atoms in there. Now imagine one day you are walking on the street and you stumble upon a treasure chest. Okay, and being the honest person that you are, you bring it to the police, but the police say that it's impossible to track the owner, so the police decided to give it to you. Right, so now you have a treasure chest that contains some jewelry, there are coins in there, there are some notes. Now how do you deal with this treasure? Right, what is one thing that you will do? Alright, if it's for me, what I will do is I will first sort out the treasure. I'll put the jewelry in one pile. I will put the gold coins in one pile. I'll put the dollar notes in one pile, and some random stuff in another pile. Alright, why do I want to do that? Because each type of treasure, there's a different way to use them, there's a different way to handle them. Alright, so same thing when we have crude oil, when we have petroleum, it's a mixture of very small organic compounds all the way to very large organic compounds. So before we can use crude oil, we have to separate them into similar groups. Okay, and how do we do that? Let's think about it. We have a mixture of liquids that mix together. Okay, we have a mixture of liquids that mix together. How do we separate the liquids? What did we learn in the chapter of purification and separation? Now if you can recall, for a mixture of miscible liquids, the correct way to separate them is by fractional distillation. Okay, and fractional distillation works by the principle that they have different boiling points. Okay, so in order to separate the components of crude oil, all right, what do we have to do is, firstly we need to convert everything in crude oil into a vapor. All right, so what happens is that crude oil is first pumped into a furnace, right, where it's heated up to high enough temperatures to convert all the components of crude oil into a vapor or into a gas. Okay, once it's converted into a gas, it's passed into a huge column, right, a huge column called your fractionating column. Okay, so what happens to the gases when they are passed into the column is this, right? It will rise up the column and it will cool and condense along the way. Okay, so what will happen is this, that the gases, the vapors that have the lowest boiling points, they will rise all the way to the top, okay, and will be collected at the top. Okay, what happens to those vapors with the highest, with very very high boiling points is that once they enter the column, they will either solidify or liquefy, and they are collected at the bottom. Okay, so depending on the boiling points of the the components in the mixture, they will be collected at different, they will condense and be collected at different points of the column. All right, each part that's collected is given a special name. It's called a fraction. Okay, so can we use fractional distillation to separate the compounds in crude oil until we get one compound in each fraction? Answer is no. All right, so each fraction is still a mixture. All right, just that now it is a smaller mixture, right? For example, the treasure chest, am I going to further separate the coins into 5 cent, 10 cent, $1? No. All right, I will compound all the coins, all right, and all the coins will be a fraction. Okay, it's still a mixture of different denominations in the coin, but this fraction of coins, I call it coins. All right, dollar notes, do I separate them into $5, $2? No, I will compound everything as dollar notes, and it's still a mixture, but now it's a smaller mixture. So this smaller mixture is called a fraction. Now each fraction is given a name. All right, so the fraction with the lowest boiling point, which is collected at the very top, is called petroleum gas. All right, the next fraction that's being collected is called petrol, followed by naphtha, kerosene, diesel oil, lubricating oil, and lastly the one that has the highest boiling point, which is collected as the residue. It comes out as maybe a black solid or something, is collected at the very bottom. All right, so it's important for you to remember the order or the sequence of the fractions that's being obtained, all right, from top to bottom. Now one mnemonic that you can use is this: Peter Pan never kills dead lying bugs. Okay, you can come up with your own mnemonic, but anything that works for you. Right, for me, I remember it by Peter Pan never kills dead lying bugs. So Peter is petroleum gas, petrol, naphtha, kerosene, diesel, lubricating oil, and bitumen. Okay, Now, other than knowing the sequence in which the fractions are being obtained, you need to memorize at least one use for each fraction. Okay, so petroleum gas is the gas that is used for cooking in our homes. Okay, petrol is the fuel that is used to power our cars. Naphtha is the starting material that we use to make plastics or alcohols. Right, and since these things are made from a component of petroleum, we call them petrochemicals. Okay, kerosene is used as a fuel for aircraft. Long time ago, it's used for fuel for cooking, but now not so anymore. Okay, diesel oil is the fuel that is used for heavier vehicles like lorries, buses, and trains. Lubricating oil is used for lubricating heavy machinery, right, to make it work smoother. And lastly, bitumen is for paving road surfaces. All right, so if you have the chance to see how a road is made, there will be a machine that discharges some black solid, and it hardens on the road. That is your bitumen.